Okay, so, but looking at these piecewise functions, you can see, like, for example, if your x is less than or equal to -1, you plug it into this function. If your x value is between -1 and 3, not include in -1, but include in 3, you would plug it into this function. If x is greater than 3, but not equal to 3, you plug it into this function. So to evaluate a piecewise function, you really just want to make sure your first thing is just asking yourself, really, what function am I going to be going in based on these domain restrictions? So for example, f of 1, well, 1 would fall between -1 and 3. So we're actually looking at this middle function. So I would just plug it into 2x squared plus 3, and that would just be 5. For example, f of 6, you want to look at, well, where would that fall in the domain? Well, 6 is greater than 3. So, oops. So we would be looking at this bottom equation. So it'd be -1/3 times 6 minus 2. So if you work that out, that would be -2 minus 2. That would be -4. Just clean this up a little bit. F of 3, be careful, because see how it wouldn't be the bottom equation because that's not included in 3. The less than or equal to 3 means 3 is included in this middle function. So for 3, I would actually plug it into here. So it'd be 2 times 3 squared plus 3. Be careful if I don't know if you're using a calculator, but if you're plugging this in, how I would do it is square 3, that would be 9. So 9 times 2 is 18, plus 3 would be 21. And then our last one, similar idea. Since -1, like you wouldn't look at the middle function, like it would be included in this one because -1's included. That's what that less than or equal to means. It wouldn't be the middle one because, as you see, -1 is not included, if that makes sense. So we would plug it into the top one, and then I'll give you guys a chance to try some of these on your own. So it would be in that 2x minus 1. So we would do 2 times -1 minus 1. Well, that would be -3. So how about you guys take a second at your seats or at your home now, see if you can do this G function. So we have this piecewise function with these domain restrictions. See if you can figure out what function you'd plug into. Just FYI, if you're plugging it into this top function, if it falls, your answer is just going to be 2, no matter what. It's because there's nothing to plug in for like an x in that top function. So that might seem a little bit weird, but basically, if it falls in that domain or those x values, it's just going to be 2 for your y value. I'll give you guys a chance. Here, I'll put it in. You can see the answers here. The next thing we're going to start looking at is kind of how to evaluate if they give you a graph. So we've kind of already seen this in our previous section because a lot of times we were looking at piecewise functions, even if we didn't call them this. But one thing, I guess kind of one sidetrack here is when piecewise functions are graphed, they look like multiple pieces, as you can see below. We know that piecewise graph shown, we know that the piecewise graph shown below is because it passes the vertical line test. So just like how we did it in section 2.1 for any function, it works for piecewise functions as well. So your piecewise functions, if it's truly a piecewise function, should always pass the vertical line test. And so for example, like even here, like even if you drew a vertical, like you might be kind of looking at this, let me see, can I make this thicker? Like you might be looking here, you might, well, it's so dark, but you might be like, oh, well, it fails the vertical line test here. But since this is an open circle, remember that doesn't really count as a point. So it really only hits one spot. So this does pass the test, even if at first glance it doesn't. So be careful if you have an open circle or a value that's not included. So let's evaluate these. So remember, these are your x values. So all you're going to do, not make it stick anymore. You're going to go to f. You're going to go to 3 on your x-axis and either go up or down till you get to your function. So for 3, it would be here or up 3. For our next one, -3, you're going to go to -3 on your x-axis. You're going to go up or down until you find a value on your function. So it's here at 2. What would f of 0 be? I should probably have the chat open. It would be 1, right? Because you would go to 0 on your x-axis and you would see to get to your line, it's just up 1, or to get to your function. What would f of 2 be? Careful, remember, if it's an open circle, it's not going to be 1, it's going to be -1. So good, Brooklyn. Because if you, so you're looking at it right, you go over to 2, you either have to go up or down, but this point doesn't really count as a value. So if you have an open circle, that doesn't count. You're looking for a solid part of your line, so it would be down here at -1. So that's one thing to be aware of. Why does this say f of 127? -127. Oh, okay. It doesn't show up on my notes. This is like supposed to be a line. I don't know if anyone printed it off, if it showed up. This is supposed to be a straight line. So like in theory, this function would be going to the left forever, ever to the left there. So f of -127, even though it's off our graph, it would just be up 2, because this is going to be 2 for every value over that way. So I was looking at that, I was like, what the heck? That doesn't make any sense. But yeah, it's not. I don't know if it's on the notes I posted or not. I don't think it is though, because it's not on mine here. Well, it is on the one I printed, but it wasn't up here for some reason. I don't know. Something weird's happened. Well, one thing to be aware of though, if you have like a gap, let's see, does it happen? I don't think it happens on the snow sheet, but it is possible if you have like a gap on your graph, like a gap of space, and you went to like look at f of something and it was like there was no values, it is possible to have undefined. Like so, because not every function is going to be defined for every value. Like we've seen, for example, certain functions, their domains are restricted. So I'll just like, so for, I mean, this is really crappy sketch, but say for example, you had something that looked like this. And like, let's say it didn't start doing anything to over here. So if you had to evaluate like a number here and there was nothing on your function, like that would be undefined, if that makes sense. So it is possible like you like to not have an answer for all these when you're evaluating. Does that make sense? But unfortunately, there's not an example like that, but you might see that on the Delta math. I'll double check. I think I put one like that. Where it's undefined. So just be aware if you're looking and you're like, well, I don't see anything on my function there. Well, it's probably undefined. Here, well, I'm not going to bother and do this, but this is actually the equations that go with this line above. Like these are actually this, like restricted. You could also plug these x values into here and you would see you get these same answers we got, just like we did in our example above. So if you want, you could double check that it does hold true either way from a graph or this, but for sake of time, we'll just move on to our next example, where I want you guys to try and evaluate this function. So take a second at your seats, see if you can find these ones on your graph. some of these might be a little bit challenging, but we'll talk about them. A function from a graph. So you'll have some questions in the Delta Math. I was looking at them. I think I picked specific ones because I wanted you to see certain cases. But so that's like a lot of what your Delta Math so far. Some of them will be where you have a graph. Some of them will be more like where you have a function. Our last thing we're going to kind of do today is we're going to try and graph these by ourselves. I guess we'll do this quick. It says Jack claims that the graph to the right is a function, but Sally says that is not a function. Who's correct? So is this function, is this a function to the right, this piecewise? Does it pass the vertical line test? No. So Sally is correct. So I'm just gonna, instead of writing it out, but if you really want to write it, you could say Sally's correct. But our last thing we're going to try and do today is graph a piecewise function. So let's kind of see how this works. So there's really so far there's really three concepts we did today. The first is evaluating like a piecewise function when they give you like the equations. The second is when they give you a graph, and then our last concept is this graph. And those are kind of like the three takeaways or what you'll be seeing in your Delta Math tonight. So here's how you graph a piecewise function. One way, and I don't know if the notes I posted, I cut them out, at least for me. I don't remember which one I posted, but you could do like an XY table, but I think that's doing too much, especially because we already know how to graph these functions, because these are just equations of lines, like 2x plus 6, negative x plus 1. If you did have something like crazy there, you could make a table of values, but we'll just be looking at pretty simple ones to start until we learn more types of functions. So here's how I do it. So to graph this first function, the first thing you need to do is plug in -1 into your function. So like, for example, plug in -1 into that function. So if you do that, it's going to be 4. So basically our first point on this top function is going to be at -1, 4. Okay. Now that we've got our first point on this function, look at the domain. It's from x is, I don't know if it's backwards. I think it might be mirrored on my camera when I do these stupid hand gestures, but it's x is less than or equal to -1. So it's everything to this way on our line. So we're just going to kind of graph that. Looking at our line, our slope is 2. So we don't want to go to the right because our domain is restricted here at -1. We're going to the left. So our slope is up to right 1, but we want to go the opposite way. So down to left 1, down to left 1. And since it has an equal to, this is a solid circle. I should have said that. Sometimes you might have an open circle. So that's our first equation. And I know this might be a little tough. So if you're like, what the heck, just yell at me in the chat. So that's our first part. So I'm going to put that, I'll draw a box. That's going to be in blue. So that's blue on my graph right now. We'll do this next part in red. Okay, so the first thing, to get your first point on your graph, you want to plug in -1 into this function. So it would be negative -1 plus 1, or really that would be 2. So our first point would be -1, 2. Since this is just a greater than, it doesn't have the equal, this is going to be an open circle. That's why this one was a closed circle. I don't know if you remember doing like inequalities, like on a number line. Well, Um, what was, sorry, Lee, I just saw your comment. What specifically? Or if you can unmute yourself too, if it's easier to say it.
Why are we plugging in -1?
Okay, the reason we're plugging in -1 is because that's where this, in this domain, oh, let me here, let me do that. In this domain, see how it's x is greater than -1? So that's where our function, where this part of our function is going to start. So you always plug in the value that's with that inequality because that tells you where that function starts. Like that, the top function, the blue function, it starts at -1 and it's everything that, it includes -1 and it's everything that's smaller than it. The red function starts at -1, doesn't include it, but it's everything bigger than -1. So that domain, that inequality tells us where our function begins and which direction it goes. So for this red function, I'm going to go to -1, 2. It's an open circle. Oh no, not the eraser. All right, pencil. We go to -1, 2. I'll try my best. Draw an open circle. And that's important that that's an open circle because if not, this wouldn't be a function because it wouldn't pass the vertical line test. And our slope of this line is -1. So we're going to go down 1, right 1, down 1, right 1. So that would be our piecewise function. So the blue comes from that top equation. The red comes from the bottom one. Let's look at another question because this is definitely the trickiest part of today. How are we doing on time? We'll be okay. Well, this is our last thing. So I'm going to do that. We're going to do this top one in blue, and we'll do the bottom one in red. I mean, if you don't have colors, it doesn't matter, but it'll just help you keep straight what I'm doing up here. All right, so the first function, it starts at 0, and it's just 3. So we're really going to just have a line, like y equals 3. It's going to be a horizontal line. But my question is, at 0, is it going to be an open or a closed circle, since it's less than? Do you guys kind of remember, like, when you first probably did inequalities, you probably graphed them on a number line. Do you remember when you used open or closed circles? Is that something that sounds familiar? Or, but this blue one's going to be an, yeah, it's going to be an open circle. So our first point is going to be at 0, and I mean there's nothing to plug it into, so it's just going to be 3. So we're going to plot our point at 0, 3. It's going to be an open circle. And look, it's everything that's less than 0. So we're not going to draw like our line all the way across. It's just going to be going this direction because it's only less than 0. That's what this top inequality is telling us. It's x less than 0. So that's the only part of our graph that's going to take place from 0 to the left, and it doesn't include 0, so that's why it's an open circle. This red function, it's 1/2 x plus 3, and it's from 0 all the way to the right, or everything bigger than 0, including 0. So the first thing we do is we plug in 0. So we would have 1/2 times 0 plus 3. So that would equal 3, or that's really like, we just solved for like our y value. So our first point is 0, 3, which is kind of weird because it's actually the same point we just plotted. So we would have a solid dot. So really there is a dot there from the second part of our function because this is closed. Sorry, I should have said that because it has the equal to. I was trying to draw an arrow. That's not like a and our slope is 1/2. So this line would go up 1, right 2, up 1, right 2. So our red function would go like that. This one's kind of weird because we had an open circle and a closed circle on top of it. So really our function really is just a continuous thing. It's just like, so there's really no gap in this one, but it just so happened that our first point was the same for both of them.